So today I'm going to show you how to do CNC toolpaths with the FreeCAD 0.19. You can get it from the FreeCAD website. You just scroll down. No, when you go to downloads, do not choose one of the official versions, but scroll down to FreeCAD releases page, click there, and here under the release artifacts assets, you'll see there's you're going to make your choice according to the operating system that you have. And I have a bench opened here, like a design that I made in the previous video about FreeCAD 0.19. And this bench is designed in a way so that it uses one single sheet of material for all the parts. So the next step would be to create a material sheet, and then we can move on from there. So as an overview for this video, I'm going to show you how you can use the A2 Plus assembly workbench in order to make an assembly for each of the individual parts, and then how to use the path workbench in order to create a toolpath for this specific assembly, so that you can use your CNC machine in order to cut all the parts from one single sheet of the material. So here at the Fab Lab, each of us for the CNC milling week, or the CNC milling assignment, is getting a material sheet in the size of 120 by 120 centimeters. And the thickness of it is 18 millimeters, but this is one thing that is important to make sure of, is to double check the material and make sure that the measurement is precise. So here in the spreadsheet, so I have 3 parameters at the moment, so which is defining the bench height and the bench seat diameter, and also the material thickness. And the latest measurement of the material sheet that I have says it's stating that so that my measurement is 17.85 millimeters, so not 18 millimeters exactly. So this is very important before you start setting it up for CNC milling, that you double check the material thickness. We go back to the bench design, and I'm going to create a new part which I'm going to call stock. It's going to be an object that is going to define the actual stock that I'm going to use. Why did it switch there? I don't know, but I'm going to use the XY plane for it. Yeah, it's jumping back here. You just close it, and I'm going to use this rectangle tool in order to draw it. So since I know that its stock is symmetrical, I'm just going to select these two, and I'm going to make them equal using the equal constraint, and then I'm going to specify one dimension, which is going to be 120 centimeters or 1,200 millimeters. So this is going to be the size, and I would like it to be somehow constrained also. It snaps to, let's say, the center of the origin of the scene or of the coordinate system. So here it is a bit problematic to do so, because so the bench is sort of in the way. But there's a way how to get, when in the edit mode, switch between section and view and full view. So we want section view here. So if we hit this once more, so there's the full view and this is the section view. So section view allows us to see what's going on the specific plane where the sketch is. And we want to access this point over here, and we're going to select this point as well, and we're going to make them coincident. And now the sketch is fully constrained. We can close it. We use the pad in order to extrude the material to the specified material thickness. Okay, so now you have these 4 objects, and normally, let's say, normally you would expect that you just could take these bodies and assemble them together with the A2 Plus workbench. But the problem with the A2 Plus workbench is that each of the parts that you want to work with, they should be on in different files, and this is what we're going to do next. We're going to export each individual part of the bench into individual files. So I'm going to select the part, and then I'm going to go to export, and I'm going to select the step format for exporting, and I'm just going to leave the name of it the same. Click save and do the same for each other parts over here. Same for the seats, and also for the stock, because we want to use that in the assembly as well. Once this is done, we're going to create a new file, and I'm going to save it as assembly. And we're going to switch over to the A2 Plus workbench. So in order to make the assembly, we need to import all of the parts. So I'm going to start with the stock. And then I'm going to continue with leg A, leg B, and finally the seat. And I'm going to choose the top view in order to align those a little bit better already. Transform somewhere on the stock so that they do not disturb each other. Like so. And now we can use the different constraints of the A2 Plus workbench in order to match, let's say, planes. So I'm going to select this plane, that plane, and select the plane coincident constraint. In this case, I want the part to be inside of the actual stock object. So I'm going to select this and this, and another plane coincident, and flip the direction, accept. So yeah, we want these parts to be inside of the material because they're going to be cut out from the material. And then for last, so with this one, I want this face to match up with the top face of the material because I want this these pockets to face up so that we don't have to go double-sided. Plane coincident, flip direction, accept. Now if I choose top view, I'll be able to align these a little bit better. And in order to make it easier to do, for the stock, I can toggle selectability so that it's unselectable, which means that I can select these individually as parts and actually move them around. So like A, transform, like so. So that's really what I need. So what I need is that I want to, I actually want this to be selectable. So toggle back selectability. So I want to select this edge and this edge, and I just want to make them parallel. Now it's going to make it easier in order to position it in the space. So I can material. I'm going to position it like this, and then I want to take this and that edge and make those parallel. I'm going to select like B and hit transform. So now I can align it according to the other part over there. And with the seat, it's a bit easier, so you can just move it around. Don't have to rotate it necessarily. And put it where it fits best. So it fits best over here. Okay, so with this done, we can save the file, and we can actually move on to the path workbench. So in the path workbench, we see that a different set of tools has been made available to us. And the first part is to create a path job object. And we want to select the parts that we want to cut first for that. And then we can select the function to create a job object for us. And this create job dialog is going to pop up, and it's going to have these selected parts already checked over here, and we just hit OK. And here we are being presented with the this setup dialog over here, and we want to set up the stock. So normally, it's like by default, it's going to try to draw around the actual objects that you have selected, but what we want to use an existing solid, so namely the material, which is going to be the bench stock part over here. And with that in mind, also we will need to set up the origin, so we can select the. So I prefer always to set the origin on the bottom of the material, so the bottom and the left and the closest corner over here, and we can hit set origin, and it's going to move the origin over here to the corner of the material. So with this done, we should move to the output. We should make sure that the processor actually fits the machine that we are, or the machine controller that we're going to use. In our case, we use Mach 3, Mach 4. And then for the tools, we should set up the tools. In my case, I have some. I have this 8mm wood end mill over here. So I'm going to close this error box, and I'm going to click on Add, and I'm going to select a file with 8mm end mill wood and delete the default one over here. And in the work plan, this is what we're going to create as we go. So with this in mind, we can just select this here. So you see the scene changed. So we have left. So it hid the original parts. No, it moved the original parts to somewhere else.
Either we try to still fix that, or
and yeah, you can hide them for now. And it moved the actual parts that are going to be milled inside the job, and it also made a separate object for the stock. So basically, the object, the initial composition of objects, was transferred here to this milling job. Here under the tools, you see there's a tool. So a little bit about the tools. So you can access the tool selector over here. So whenever you double click a tool in the tool selector, it's going to add it to your job. So it'll be used in one of the operations that we're going to set up in a minute. And you can also open up the tool library. So if you open the path, if you work with it, if you create a job the first time and you open this the first time, it's going to offer you to select a directory, to choose a directory where to store all your tools. So as a tip for that, I set mine up here under Home FreeCAD Path Tools. So it's a visible folder where I can always check what is going on with my tools. So here I have the tool shapes. Here I have the libraries, and here I have the actual bits that I specified. So the bits are based on the shapes, and then the libraries are based on the bits. So all the tools referenced in library, they are can be found here, and all the tools that can be found here, they are built on top of the basic shapes that can be found in the shape directory over here. That's that. So I made a separate library in the Fab Lab. There's a default library. So here, So I plan to add several tools that are specifically related to the AutoFab lab. I added an 8mm end mill already. So I'm gonna create a new tool. So I'm gonna select an end mill shape, and I'm gonna call it a 6mm end mill wood, like so. And yeah, and then I'm gonna hit close, and I'm gonna double click this one in order to add it to my job as a tool control, and I can get rid of this other 8mm job. So if I double click on the job and go to the tools, I'll see that yeah, now the 8mm tool has been replaced with this one. I think that I didn't cover one essential thing. Like, there are some parts that you can modify over here that you should modify. So for 6mm tool, you should specify that the diameter is actually 6mm, and our shank diameter is going to be 6mm as well. So with the cutting edge, I'm going to set 20mm, and for the length of it, 50mm. I'm going to go with 40. And then there are other attributes, so the chip load of it. So this is this really depends on the lab and the tools that they are using. But for a 6mm tool and the soft wood, I would go with chip load of 0.2mm. Flutes, it has 2, and that's pretty much it. I'm gonna hit OK and close, and delete this one, and then add it again just in case. So then for the job, I can select the job, and I can add the first operation. Another thing for the tool. So here you need to set up the spindle speed. So our machine can go up to 24,000 revolutions per minute. So here I'm going to set the spindle speed to 20,000, and the direction is going to be forward. Then here I can set the feed rates, and knowing that we have a 0.2 chip load and 2 flutes, I'm going to use the calculator to figure out the horizontal feed rate. The calculation is really easy because you need to specify the number of flutes, then you multiply it with the chip load, which is 0.2, times the spindle speed, which is 20,000. We end up with 8,000 as the feed rate. Enter it here. So, and for the vertical feed rate, I usually set something that is 1/4. So this time it's going to be 2,000. There's a really interesting thing over here. Why does it want to accept 8,000 straight? Okay, now it's accepted. And the rapid moves. Oh, that's weird. Okay, I'm going to just leave it like this. Rapid moves, you can set them approximately. So not approximately, but you could set them the same. Setup sheet horizontal rapid. So instead of maybe modifying them here, set them up in the setup sheet. So let's go to the setup sheet. Here's where you can set the clearance, 5mm fine, save height 3mm fine, horizontal rapid 8,000. Close this one, and then the vertical rapid is going to be the same. So probably these could be faster, but yeah, it depends on your machine how fast it can go. Then the job. So we can create the profile toolpath to cut all of these out. So let's do that. And that's relatively easy. So all we have to take care about is that it cuts outside, and the direction is clockwise, and that the right tool is selected, in our case the 6mm end mill tool. Then for the depths, we're going to start, we can leave the same start depth, but we want the final depth to be a little bit below the stop level. So in order to set that, we'll set minus 0.2. And for the step down, I'm going to choose something that is less than the tool diameter, and in my case I want to divide it by 2. So it's going to be 3 millimeter step down. And what else? These errors over here. For the heights, it's going to take the heights from the setup sheet. And here we can hit OK. And it generates these paths over here. If you look from the side on them, you will see that the green line, the last green line, is a little bit below the surface of the stock. So this is exactly what we want. But what we don't want is that on the last line to be cut, that these are flying out. So we want some tags to hold these in place. So the cool thing about FreeCAD is that you can add the tags on the G-code level, so you don't have to modify the original geometry in order to do so. And the way you do it is you open the operations, you go to Profile, you right-click, and you can add these dress-ups over here. So there are different kind of dress-ups. There are dog bone dress-ups. There are tag dress-ups. This is exactly what we need. There's several things that you can do with the existing G-code. And maybe before we do that, we actually want to add the dog bone dress-up, so that we need the parts to fit together. And if we don't do the dog bones, so you don't need also to modify the geometry. So if you don't have the dog bones, then these the parts are not going to fit nicely together. So the rectangular parts are not going to fit precisely into the slots where they're supposed to go in. And so you right click, and then you go dog bone dress up, and what it created these G-code path extensions for the tool to go a little bit in the corner in order to generate this dog bone over here. And so as for the dog bone dress up, on top of that we can add the tag dress up. And for tags, we need to enter the geometry of those. So 8 millimeters is fine, so 3 millimeters in height, and I prefer it to be 90 degrees in the angle, so that they are like little bridges instead of little mountains. And the radius, yeah, I don't need a radius over here. When I click on Add, can move closer to the actual toolpath and can select exact points where I want to add the tags. In this case, I'm just going to add a few. If you have a really stable vacuum table, you might not need those, but for smaller parts, even on a vacuum table, it is better to have those, because the vacuum table is not always holding the parts down, at least in our case. And hit OK. Now when you zoom in, you will see that the G-code is modified so that steps over a certain location, so it leaves some material over there. The next thing is that we want to create pockets over here. And we can do so by selecting these individual faces where the pockets are, and we can create a path pocket object. Clicking the button, and here we can specify the depth. So how I think it's this is not so important, because like it's gonna automatically take the depths of the pockets already. Depths, heights, operation. Here we can specify the shape, and if you hit apply, you will see how the shape is being applied. You can also specify the step over percent. In my case, I'm going to set it to 40 degrees. Operation itself. So yeah, you need to select the correct tool, the cut mode, and the angle. So you can go also in the 90 degrees. So if I set it to 90, it's going to be right angle, almost. Oh, that's interesting. Not what I expected. So I'm just gonna leave it to 45. And you can also select the zigzag offset, but so what here is important also to have the dog bones, and with the pocketing operation, adding the dog bones is not so straightforward, so it doesn't add like automatically. This is why I'm gonna create a separate cut path for this one in order to make the dog bones and apply the sort of the path dress up for that one. So here when I hit OK, it's gonna calculate me this. I'll open it up one more time because I think I could modify the step down, and I could go half the tool diameter over here. And now it generated me a bit more levels for the cutting. And on top of that, I'm going to select the same geometry, same faces over here, by control clicking, and create a profile. Depths. And here I'm going to select the step down. I'm wondering if it's going to create what I want. Yeah, it did. So the profile, so here I selected it. So it's important to select the inside. And for the profile, I can now add the dog bone dress up. Just going to take into account the tool diameter and create extra paths for the dog bones. And that's pretty much it. So what you can do now is we can close this job, select it, and we can go to simulate path. And it's simulate us the paths. So you can select the speed and reduce it a little bit so that we can see what actually happens. And here it is, our tool, 6mm tool, actually cutting along the paths. Yeah, that's the way how you create the tool paths. And the next part is to just double check that you have the correct processor set up over here. And in our case it's Mac 3, Mac 4. Then you select the job and you hit on post process the selected job. And you go somewhere where you want to save it. I'm going to make a new folder, paths, and name it as 6mm all. Bench 6mm all. Save. It's also previewing the G-code. Hit OK. That's that. And now you can just move on to the CNC machine of yours, load it in the machine controller, and run the job.